Okay, this is a tutorial for section 4.2, and that's factoring sums and differences of cubes. Now the camera died out last when I was taping this, so I just kind of kept some of the notes here because I just started it, so I'm just going to redo it here. So we have two formulas for a sum of cubes and a difference of cubes. There's two specific patterns, I guess is what you could call them. And here we have the first pattern for the sum of cubes and the second pattern for difference of cubes. And that's also found in your textbook on page 117. Now, to recognize a sum or difference of cubes, you have to know that there's two terms and they're perfect cubes, and they're either added or subtracted. And depending on if they're added or subtracted, you use the first or second pattern. Now, there are basically in this area, specifically, about 2 or 3 different kinds of problems that you're going to see. Now, the first problem is, that I've written here is 125 minus 27x cubed. Now, what you do here is you recognize that that is a perfect cube in the first term and also in the second term, and that there's a subtraction. So you're going to be using this pattern here. So you would have to just find or calculate or figure out what is the cube of 125, and keep that as in mind, that the a would represent 5 in that case, because that's what it is. And what is the cube of this 27x cubed? Well, the perfect cube of that is 3x. So recognize that this is going to go to 5 and that this is going to go to 3x. And then you would just plug that into the formula here, which I did here. 5 minus 3x times 25, because a squared would be 5 squared, plus 15x, that's positive a times b, which would be 5 times 3x, plus b squared, in our case 3x squared, which is 9x all squared. So, or not all squared, squared, pardon me. And that would be our first example. The second example that I have here is sometimes you have an example with common factors. So you must remove here a common factor out of this expression. And we can see that we can take out x, and we can also take out 3. Because 3 can be divisible into 81. So that's the first step. Take out your 3x. Then you get 3x times 27x cubed plus y cubed. Now you recognize that 27x cubed is a cubed term. If you take out a 3x and multiply it 3 times together, you would get 27x cubed. And also y. So this here is going to break into a 3x if you're cubing it. And this here is going to be y cubed. So we just use the pattern for the top one and plug it in. So I plugged in 3x for a and y for b in the bottom one, and I ended up with this expression. 3x, we left it out here, times 3x plus 9, or sorry, 3x plus y, and then times 9x squared minus 3xy plus y squared. And that would be our second example. Now there's a third example that you can have, and I didn't quite get to that one when the camera died, but we'll look at it now here. I'm just going to move this up a little bit. And that's where you're going to have a similar example to what we did in section 4.1, where we had to use secondary variables. So if I had an example that looked like something like this, let's just make a real simple one. If I had x minus 1 all cubed plus 27. So this could be recognized as a perfect cube here, and this is also. So this is a sum of cubes. So we could say that if we use a capital W, again, to represent our x minus 1 in this case. So that would break down into w cubed plus 27. Now we can use w as the a term in our kind of our formula. And 27, the cube of 27 would be 3. And we could use that as well. So we could sub this into our formula now. So it's a positive formula, so we have to use the top formula. And as we go, we would have w plus 3 multiplied by w squared minus w times 3 plus 9. Okay, then we plug back in our terms for what w represents. So that's x minus 1 plus 3. We can see we can simplify that later. X minus 1 all squared. So we kind of have to have brackets inside of brackets there. And minus, and I'm going to put the 3 in front so that we can do that 3 times x minus 1 plus 9. And we can see we can do some reducing in this problem. Let's reduce this. X plus 2. Just let me check the field of view, make sure we're still okay there. These batteries are going dead as well. Working this one out, this would be x squared minus 2x plus 1 minus 3x plus, or minus, sorry, not plus there, minus 3. Or no, I was right, plus. 2 minuses make a plus, right? Starting to think too much. That's a plus sign there, plus 9. So simplify this, and that's all in brackets there. Okay, so this is x plus 2, and this can be simplified at x squared minus 5x plus 10. Or pardon me, that would be plus 10 minus 1, so it'd still be plus 9. And that would be our final example for our cubes. So we'll stop there, and in our next section we'll be looking specifically at trinomials and factoring high degree trinomials and polynomials.